Imagine waking up tomorrow to literally the biggest breaking news in human history. Every telescope on Earth has simultaneously detected this massive, glowing portal just floating right in our cosmic neighborhood, barely beyond the moon's orbit. It's this swirling doorway, twisting space and time, pulling at the very fabric of reality itself. Welcome to The Explainer, presented by Last Human Era. Today, we're exploring an absolute, ultimate science fiction scenario brought to life. So, what would humanity actually do if we found this kind of anomaly just hovering out there in the dark? Well, at first, the global scientific community would be completely scrambling to explain it. But after months of totally exhaustive research, they'd reached this astonishing conclusion. It isn't a black hole at all. It's actually a stable wormhole, a theoretical shortcut through space and, yeah, possibly even time. Section 1. The Cosmic Shortcut. Okay, let's actually dive right into the astrophysics behind this phenomenon. Because while it sounds like pure Hollywood magic, the foundations for this have literally been sitting in our textbooks for well over a century. What we're really talking about here is technically called an Einstein-Rosen bridge. You see, the very first study of wormhole physics was actually done by Ludwig Flamm way back in 1916, right while he was researching solutions to Einstein's field equations. Then jumped to 1935, and Albert Einstein, along with Nathan Rosen, expanded on this. They mathematically proved that a black hole's surface could, theoretically at least, act as a bridge connecting two entirely remote patches of spacetime. To kind of visualize all this complex math, just imagine our universe as a flat, two-dimensional sheet of paper. If you want to get from point A to point B, you normally have to travel the long way, all the way across the surface, right? But if you fold that paper so those 2 points touch and punch a little straight through, boom, that's your wormhole. It's the ultimate cosmic shortcut. Section 2. Danger in our backyard. Because having a literal tear in the fabric of spacetime parked right next to the moon isn't exactly a peaceful, scenic scenario. In fact, it'd be incredibly dangerous for us. The sheer gravitational pull of this anomaly would wreak absolute havoc on our planet. We'd instantly see GPS satellites glitching out and dropping offline. We'd start experiencing these unpredictable, massive tidal fluctuations in our oceans. Telescopes would be picking up terrifying spikes in radiation. And worse, wormholes aren't necessarily stationary. This thing could drift through our solar system like a cosmic tornado. And if it were to become unstable and just collapse, it could release the explosive energy of a supernova literally right in our backyard. And this brilliantly illustrates the massive gap between the movies and reality. Sci-fi wormholes are always depicted as these stable, traversable, scenic routes across the galaxy. But theoretical reality tells us that natural wormholes would likely be microscopic, intensely radioactive, and extremely prone to instantly collapsing the exact second anything tries to enter them. Section 3. Spotting the invisible. So with all that chaos, how do we actually verify that the swirling vortex is a true wormhole? And not just, an ordinary black hole that's getting ready to swallow us whole? Well, we'd have to look for the invisible. Astronomers would be searching for something called gravitational lensing. That's where the immense gravity of the wormhole acts like a giant magnifying glass, bending the light of galaxies sitting behind it in a very unnatural, distorted way. But honestly, more importantly, they'd be looking for weird star wiggles. Cosmologist Dejan Stojkovic explains this perfectly. He says, if you have two stars, one on each side of the wormhole, the star on our side should feel the gravitational influence of the star that's on the other side. The gravitational flux literally travels right through the tunnel. Scientists are actually already keeping an eye on stars like S2, which orbits near the center of our galaxy, hoping to detect these exact kinds of perturbations. Oh, and real quick before we continue, if you're enjoying these mind-bending future scenarios, make sure to like this explainer, share it with a friend, and subscribe to Last Human Era for more incredible journeys into the future. Section 4. The one-way probe. Assuming we do confirm it's a wormhole, just imagine humanity standing one single mission away from reaching distant galaxies in hours instead of millions of years. Space agencies would absolutely race to send probes right through that mysterious gateway. Based on an actual computer model by physicist Ben Kane, here's exactly how that mission would play out. Step 1, a probe made of normal matter enters the portal. Step 2, the very presence of that normal matter causes the highly unstable wormhole to begin pinching shut, basically collapsing into a black hole. But step 3, Step 3 is the payoff. The collapse happens just slowly enough that a fast-moving probe could beam a light-speed video back to our side. When that first signal returns, it reveals these breathtaking images of an entirely different star system, completely unlike anything we've ever seen, right before the door permanently seals. This kind of discovery would ignite an insane new space race, as nations compete to become the first to cross the cosmic bridge. But as Kane puts it, it's just the capsule and a video camera. It's all automated. We aren't even trying to get the probe back. It's a guaranteed one-way trip, done strictly to get a glimpse of what is on the other side. Sending actual humans? That is absolutely out of the question under normal physics. Section 5, the ghost matter problem, which naturally leads us to the ultimate roadblock here. Why can't we just engineer a way to keep the tunnel propped open for a safe return journey? So the crucial point is this. To stop the wormhole from snapping shut the very second you touch it, you need something called ghost matter. This is an incredibly exotic, purely theoretical form of matter that possesses a negative energy density. Mathematically speaking, it's literally the only way to push outward against the crushing gravity of the tunnel and keep it stabilized. And to be totally blunt with you, we have absolutely no idea if ghost matter even exists, let alone how we'd manufacture it. As Dr. Stokevic humorously points out, to create a huge wormhole that's stable, you need some magic. It's a pretty stark contrast to the bright optimism we always see in science fiction. Section 6, a time travel paradox. But hey, let's play along. Let's assume we actually find the magic and stabilize the portal. We'd very quickly realize the universe has completely other plans for us. Because as humanity prepares its very first crewed mission, really strange problems start to appear in our simulations and probe data. Some probes return with missing data, others seemingly arrive before they were even launched. And a few, well, they just never return at all. Scientists would begin to fear that the wormhole doesn't just bend space, it might actually distort time and reality itself. Theoretical physicist Kip Thorne established exactly why this happens. If you take one end of a wormhole, put it on a spaceship, and accelerate it near the speed of light, time is going to flow differently for that moving end compared to the stationary end back on Earth. You essentially desynchronize the two mouths of the tunnel. So you haven't just built a space bridge, you've literally built a time machine. The consequences of this are, quite frankly, reality-breaking. You could enter the wormhole and emerge hours, days, or even years before you even left. You trigger the classic grandfather paradox, where you could theoretically alter history or erase yourself entirely. And then comes the most chilling discovery of all. Faint signals start emerging from the other side, but they aren't from aliens. They appear to be distress messages sent by future humans, desperately warning us not to enter. And this is exactly why many physicists believe the universe has its own built-in defense mechanism. They argue that nature simply will not allow time-traveling paradoxes to form. The very moment a wormhole is positioned in a way that allows time travel, quantum fluctuations would cause it to instantly and violently collapse. By the way, if these crazy future possibilities fascinate you, don't forget to like this explainer, share it with fellow space enthusiasts, and subscribe to Last Human Era, because every single week we explore the most unbelievable futures humanity may face. In the end, a wormhole appearing in our backyard could become humanity's greatest scientific breakthrough, a literal key to the cosmos. Or it could be a doorway to a fate we were never, ever meant to discover. But I'll leave you with this one final thought. If the first mission through the wormhole had room for only one passenger, would you step inside, knowing you might never return? Let me know your answer down in the comments. Thanks so much for watching.